Welcome everybody. We are going to talk about Vitess. The name of our talk is Failure is Always an Option. What we mean by that is that when you are running distributed systems, failures happen. And the number 2 has a story behind it. Sorry? Oh. Failure is always an option. Okay. So what I mean by that is that when you're running a distributed system, network partitions happen, pods get evicted, and failures happen. And your systems need to deal with it. That's what we're going to talk about. How to build a resilient global database platform using Vitess.
Go walk away over there.
Okay.
No, so you're not near
please.
these mics.
Yep. My name is Jiten Vaidya. I am the CEO of PlanetScale, which is a company that helps people run Vitess clusters. I am the CEO of PlanetScale. Sugu, who is here, who is the main developer for Vitess, and I used to work together at YouTube, where Vitess was born, to scale YouTube's databases. I ran YouTube's SRE and DBA teams that operated the Vitess clusters. With me, my co-speaker is Dan Kozlowski. Dan and I work together in Washington, DC at the United States Digital Service, which is a small government department that helps the US government to run their IT more efficiently. And Dan used to be the chief cloud architect for the Veterans Administration in the United States. If you just go by the budget, that would be in top 50 companies in the world or something like that. When I asked Dan to come and work with me building PlanetScale, he had one condition, and that was that he wanted to choose his own title. So let me present the Minister of Engineering at PlanetScale, Dan Kozlowski. All right. So let's start off by talking about Vitess, right? The Vitess architecture. So the reason that I wanted to start out here is that first let me describe to you how Vitess works, and then we can think about how to run it A in Kubernetes, B in multiple Kubernetes clusters across multiple data centers, right? So what you see on the left-hand side of this line are the app servers. You know, these are stateless servers, presumably running in their own pods. Maybe there are some batch jobs that are running every night, so on and so forth. All connect to an L4 load balancer, which are backed by many instances of VT-gate process. Okay, so VT-gate is a stateless proxy that has a full MySQL parser built into it, and that speaks the MySQL binary protocol. So when these app servers connect to the load balancer, as far as they are concerned, they are connected to a single humongous MySQL database, right? So many VT gates, all stateless, they connect in turn to the multiple shards that represent a key space. So a key space with a single shard is exactly identical to a database. But when you shard it, you have n shards all with the same schema that represent a key space, okay? Each shard is a MySQL cluster with one master and multiple replicas. And what is not represented here is the dimension of multiple cells. So Vitess supports this notion of cells, and a cell is nothing but a failure domain, right? In a data center, a rack might be a cell. Maybe in a cloud provider, an availability zone might be a cell, or a region might be a cell. So depending on how you are architecting your environment, a cell is a failure domain, right? So in every shard, the master and the replicas can be distributed across multiple cells. So Vitess knows about cells from ground up, right? And the reason that Vitess knows about all this and is so good at running in Kubernetes is because in Google, it used to run on Borg, which was the precursor to Kubernetes in Google, right? So Topo server is basically where all the cluster topology is stored. And in Kubernetes, typically it's an etcd quorum, but it can be a zookeeper quorum or it can be a console quorum. We support all three because again, in Google, you used to use something called Chubby, which is Google's log server. VTCTLD is the control panel, and the control panel gives you a web UI. I think Dan will be showing us that web UI. And you can also send command lines to it, right? The same commands that you can use the web UI to execute, you can also send them through a multiple command line tools. So that's Vitess in a nutshell. Also want to mention, just one second. The Topo server is not part of the query path, right? So Topo server has the information about how a particular key space is sharded, as well as the information about the cluster topology, but all that information is cached by these VT gates, so that even if your Topo server goes down, your query path doesn't suffer. Okay. Next slide. So why Vitess? So we are going to do this global resilient database using Vitess. Why is Vitess ideally suited for a system like this? As I said, VT gate is a stateless entry point that allows scaling. If you suddenly need to add 1,000 more app servers, you increase your VT gates to 100 or something like that, and your system scales, right? There is no connection, number of connections issues and so on. You can, depending on what you want, you can scale up and scale down the number of VT gates. Every MySQL in the system gets a VT tablet process, which is a minder for that MySQL. And VT tablet also has a full MySQL parser built into it. VT tablet does things like connection pooling to the MySQL. It puts a timeout on every query. It puts a timeout on every transaction. It has things like hot row protection built into it. So in general, your MySQL is a lot more robust running underneath the supervision of a VT tablet than otherwise. So even for a single non-sharded MySQL cluster, it will perform a lot better underneath Vitess than otherwise. So VT tablet is really useful. Basically, all of you probably have had experienced when an inexperienced developer writes a query that brings down the whole MySQL database, a query of death. That pretty much doesn't happen underneath Vitess, because Vitess will kill your queries that are returning too many rows or that are running for too long, right? I see a lot of knowing smiles here. Native backups and restores. So when you have multiple MySQL clusters, you need some automation and help around managing backups and restores, and also a process for bringing up new tablets, which doesn't involve a database administrator figuring out how to bring up a new tablet and so on. So there is automation built in Vitess, which figures out, oh, I'm a tablet, I belong to this shard of this key space. The last backup was taken for this shard and this key space at such and such a time. This is the S3 bucket name for that. Let me go get all of that. Let me start my MySQL, and let me start my replication logs from the current master, bring it up to a certain threshold, and start serving the traffic. All of that automation is built into Vitess using backups and restores. So bringing up new pods serving data is fairly trivial. Health checks and observability is also built into Vitess, and because of that, again, I mean, something that is absolutely necessary for running a distributed system in Kubernetes, right? Another nice property of Vitess is that all of the middleware that I talked about, so VT tablets, VT gates, they are all pretty much stateless. And the state is either in the client, which of course needs to know about the key space that it is talking to, or it's in the databases where you're actually saving the stateful data, right? But all the middleware is completely stateless. So that's another good property. Next slide, please. So this is again, I talked a little bit about cells. You can support multiple cloud regions using cells, and a cell basically represents a unit of availability and also locality. And you can run things under multiple Kubernetes clusters. Also, because there are multiple shards, you can scale your writes as well as you can geolocate the data. What I mean by that is that if you have users in Japan hitting application servers in Japan, you can make sure that their read queries are served by the read replicas in Japan rather than from the masters in Mountain View. All of this is again built into Vitess. At YouTube, the biggest key space that we had was 256 shards, so 256 masters. Each master had between 80 to 120 replicas distributed over 20 cells globally. So 4 to 5 replicas per cell in 20 cells globally. And when people connected to app servers running in those data centers, the read traffic was load balanced across replicas running locally. It's only if somebody wrote something that went to Mountain View and was then again replicated out everywhere. Next slide, please. Okay, I'm going to hand it over to Dan.
You can hang on to that mic. I think these ones are on. All right. So, Jiten has told you a little bit about what the global stateful Kubernetes app looks like, but we wanted to show you what a global stateful Kubernetes app looks like. So what we've done is we've set up a little demo here. I am going to need your help, so just stand by. What you see here on the screen is the architecture that I have put together. I would have loved to show it to you live, but it does take just a little bit too long. So we have 3 different cells provisioned. 2 of them are here in Europe. This is all in Google GCP. So we have one in the EU West 1 region, one in the EU West 4 region, and then just for kicks and giggles and because I ran out of quota in Europe, we have one in America. So we have we have the United States East 1, EU West 1, and EU West 4. Each of them are running a set of application servers and a set of Vitess shards. They are all fronted by load balancers, and I'm actually not sure what's going on with the Ingress because I know Google has a global cloud router, and it appears that everybody here at this conference is in fact hitting the EU4 region, and that may be Google shenanigans. I'm not sure. But this is generally what it looks like. So what I need all of you to do, go ahead and grab your phones and head out to doggo.planetscalelabs.com, and what you're going to see is the world's next big app. It's a little bit self-explanatory, but I'll give you a demo so that you can help me. What you're going to be doing is generating some load for this cluster so we can actually show what's going on. I'm going to swap screens real quick. Nope. I don't know what that was.
I think that app is pretty self-explanatory.
Oh, yeah. Okay, so what I need you to do is I need you guys to start rating the dogs for me. And
doggo.planetscalelabs.com.
yes. All right, let's try that. And of all the technical things that we're going to break, I did not think it would be this one. All right, we'll just...
And also note to everybody, they're all good dogs. Please give them good ratings.
All right, there we go. Cool. Nope, not yet. Okay. All right, so now we're back live. All right, so you all should see the goodest doggo. You should be able to rate the goodest doggo. Okay, so here is our nice little Prometheus cluster. Let's see how good you're all doing. Oh, beautiful, look at that. All right, so we've started to generate some traffic on there. What I want to do is walk you through a little bit about the environment and then show you some common failures that we have. So here is the Vitess dashboard. This is all part of open source Vitess here. You see that I have two key spaces, one called doggers, one called lookup. Doggers is split into 4 different shards. If I go into one of those shards, you can see the layout of the tablets. I have a lot of read replicas here, mainly because I'm lazy, and I was really hoping this would take off and be the next big thing, so just optimistically provisioning here.
Point out that the master is in EU West 4 and the replicas are distributed in.
Right, so right now the master is currently being served out of EU West 4, which again, that is the region, I believe, that is closest to Spain here. I may have been wrong about that, but what I'm also going to do is I also have, for demonstration purposes, I have a little script here that is just writing some automatic ratings into the application. Don't worry, they are all very good ratings, so we're not doing anything mean to these dogs. And then I have a few other tablets to go through what's going on. Other things that I want to introduce you to while I'm here is this is the VT Gate interface. So the VT Gate interface shows us a little bit about query traffic that's going on. Again, we have a number of these. So the traffic that you see here is not necessarily going to match up with the traffic across the whole cluster. To do that, we rely on Prometheus, which all of the metrics are exported by Prometheus. So we have great visibility into not only the queries coming in, but how fast they're being serviced. And there was a little bit of enthusiasm there for a bit, but then I guess people got tired of rating dogs. So we're still at a healthy 20 queries per second. So the last thing I want to introduce is this is a tool called Orchestrator. This isn't technically part of Vitess, but we integrate tightly with it. I don't know how many of you are familiar with Orchestrator. It's a project by GitHub. This integrates natively with Vitess. So we can also see here, just like in the Vitess dashboard, I have all of my shards. If I go into one of my shards, I can see all of my replicas, and I can see how they are responding. Great, nice and easy. Okay, so obviously there's a few things that we may want to have to do with this cluster. So let's say that we realize that we are getting a lot of traffic in a different region. Right now, all the masters, like I said, I think all of them, are located in Europe, or maybe not all of them. I have 4. Okay, so all of my masters are in Europe, but maybe I'm getting a lot of traffic coming in through another region and I want to optimize a little bit. What I can actually do is I can do a planned reparent. So I will pick one of my shards and I'm just going to click on the hamburger, click on planned reparent, and go ahead. And now I'm actually going to change the master to one that is in cell US West 1. Looks like 2001 is in US West 1. I'm just going to go ahead and pick it and reparent. It's going to think about it for a little bit, and it's going to say, good, I've successfully reparented. Now, if you are rating dogs furiously, you'll notice there was no interruption of traffic there. And I can go back to my command line app, and I'm just chugging along. Vitess can actually switch between who is the master completely transparently to the applications using it. So we can swap between different regions. We can parent away from nodes if we have to put a node into maintenance, or if we want to cycle nodes in and out. So we can go ahead and do that. So that's the first fun thing that happens. The second thing that happens is things fail, right? So obviously things fail. Let's make things fail. So kubectl get all. Again, this is running in 3 Kubernetes clusters across 3 regions. There's no federation going on here because I don't really trust federation. And I think that's generally how we all feel at this point. So I actually have 3 different Kubernetes clusters. Thankfully, Vitess works really well in that situation. We just have a global lock server and a global orchestrator, and then Vitess handles the coordination between the 3 of them. So I am in US East 1. I'm going to go ahead and make sure I don't kill a master, but I'm going to go ahead and kill tablet 2003. So find tablet 2003. Oh, that's US East 1. Nope, so I don't want to kill anybody on US East 1. There you go. All right, so actually I can kill anybody on US East 1. But, I mean, that's not terribly exciting. So we'll let that guy die. Again, this could be, right now I'm deleting it. You know, I'm a silly sysadmin who's just randomly deleting stuff because I don't know what I'm doing. But again, if this was actually when we were preparing for this talk, something happened to my Kubernetes cluster, node went down, tablet went down. It happened to be the master, and I'll show that in a bit. But it responds the same way, whether it's a hard failure or me deleting it. So we haven't done any tricks with like delete hooks or anything like that. There's no sleight of hand going on. I am just deleting a pod. So that's gone. I'm going to go ahead and switch contexts real quick and get to the European context and go ahead and delete tablet 2002. Okay. So while it's going on, let's make sure we can still rate some puppers. Oh, you're a good dog. You are too. 13. So I don't know if you noticed on your phones, the scale actually goes to 13 because these are the goodest doggers. They're not just normal doggers. Okay. So we're still able to rate. We can see here in VT-Gate, I'll go ahead and refresh it, and it's telling us that some of the replicas are down. The test doesn't really, it lets you know that it's down, but because of those health checks that Jiten was talking about, we're not going to see queries fail. We are actually going to see Vitess knows immediately, within a fixed amount of time, that a tablet has gone down, and it will in fact reroute all your queries seamlessly. So, traffic chugs along normally. So there's that. The next thing that can obviously happen here is we could have a master tablet fail. So master tablets are used for all of our writes. So let's go ahead and find where one of the masters is. It looks like the master for the C0 shard is located at 2001. So let's go ahead and kill that one. Orchestrator is still pretty happy. It hasn't detected any failures, which is about right. Actually, it has detected failures. Now that it comes up, you see those two black dots. Those are the tablets that it thought were there that are now gone because I deleted them. So let's go ahead and kill a master. All right, so I'm going to kill 2001. Boop. Okay, so I've now unplanned killed the master. It is now gone. In a normal database world, this is kind of catastrophic, right? Also, all of these pods are completely ephemeral, so there's no persistent volumes backing these up. They are actually running on empty, empty drive? Empty disk. Storage. So killing this master here, I have actually killed everything. We have two ways that we mitigate against this. One is we turn on something called semi-sync. So semi-sync is a MySQL feature that before we actually accept a transaction is committed, MySQL will wait until at least one replica has written it to its bin log. Now it hasn't applied it, but it has put it in the bin log. And MySQL will actually block on that. So the fact that I have now killed this tablet, what we should start seeing here is some of these inserts are starting to fail. We can see, if I were to just stop this for a second, you can see that the C0 shard, that's the master I just killed. Some of those inserts are down. Thankfully, Orchestrator is there to save the day. So Orchestrator has detected that there is a failure. And because it's detected there is a failure, it is going to do something about it. So Orchestrator has recovery. The recovery is currently waiting to find out who the successor is. What Orchestrator does is, like I said, with semi-sync, you know that transaction was written down to at least one place. So what we need to do is we need to find where that transaction was, and that's the person that needs to be master. So right now, Orchestrator is actually evaluating the GTIDs of all the replicas, and it's going to determine the one that is most suitable to be the new master. So it has picked one. The successor is is this host. Doesn't mean a lot to us here, but we can see it back in the VT tablet part. It is promoted the OK master, and it is now going through the rest. It's going to apply some changes to it. It does take a little bit of time. If I go back here, what we should see in a few seconds is all of these queries start working again. And again, this only affected that one shard. So if you are furiously rating dogs right now, you would have noticed that some of those would have returned errors, but generally it would only have been a quarter of requests. And we're back, we're live. We have recovered from that failure. So and again, this could be any number of things that happened here. I happen to have deleted that tablet, but let's say you had the node go down that was on it, the backing node unexpectedly fail. These things happen. It would have recovered, or if any other number of unhandled events would have occurred. So if your disk filled up and you couldn't write to it anymore, if a pod got evicted, So when pods get evicted, they sit around and they normally require human intervention. Orchestrator can handle that automatically for you. But wait, there's more. So that's the case of one node going down. What happens if, say, like a whole data center goes down?
Ooh,
so,
you're not going to do that, are you?
Okay, so let's just say something happens here in Spain, and use context. I'm going to go ahead to Spain, and I'm just going to say kubectl delete US West, EU West 4.yaml. Just go ahead and do that. And now I have actually done something very bad. I have deleted every single tablet and every single shard and all the VT gates that are powering that. If you are actually still furiously rating, you may have noticed now that the app will no longer work. So if you keep trying to do it for a little bit, you may see it hang. That's because, again, I'm pretty sure Google is routing all of us to this specific data center, and I have just deleted not only the database, but I've also deleted its VT gates. So the database connection for these app servers are down. So I haven't actually been able to figure out why this is. I promise you, and I did this in America, I didn't get this problem. So if you're trying to rate dogs now, you'll see that that is in fact failing, and we can see the test is very unhappy. This is going straight into the other European data center, and all of those writes are failing. All right, so if we go back to Orchestrator, however, we see that Orchestrator has detected some more failures, right? So we now have failures for all of our shards almost, and I can go ahead and look at recovery. So I see that I have instantiated a recovery for C0-, 4080, -40, and ADC. So this is all of my shards have now been affected by this. Now you will not be able to commit anything until this is fixed. So again, Orchestrator is doing the same song and dance that it did last time. It is going through all of your replicas. It is trying to figure out which one is regrouping replicas via GTID. So it's going through all your replicas, figuring out which one has semi-synced all those transactions. We don't want to lose a single rating. These doggos are not something we want to lightly brush aside. Once it figures out who they are, it'll go ahead and recover. It's actually possible to do this a little bit faster if you are not putting this in the most suboptimal situation. Again, I'm failing over between regions. So Orchestrator actually has a mode where it will explicitly disallow this. If you remember back around 6 or 7 months ago, there was an outage at GitHub. That outage was caused by Orchestrator failing over between data centers, which caused a little bit of data problems for them because it was tuned a little bit too aggressively. So right now, I do have it turned on to fail over across data centers because I wanted to show taking down a data center. In reality, this may not be how you decide you want to run it. Your needs may vary. All that aside, let's see how it's doing. Okay, so it has picked a master, it has picked a successor, and it is starting to apply changes. I'm going to go back to VT-Gate. VT-Gate's going to be very red right now. Yeah, see, it's unhappy. It is very unhappy. And we can see that at least one of the shards has a master, and let's wait to see the other ones. Okay, Orchestrator is doing its thing. Okay, so it's picked the master. It's now going through the recovery procedure on that master. Also, this is not a global orchestrator. I kind of cheated here, and I only put Orchestrator in one data center. So all of this recovery is actually happening across data centers as well. Orchestrator has a mechanism that you can run as a Raft consensus group, which is how we would run this in production and how we set it up at PlanetScale when we run Vitess for people. Okay, so now it's done its thing. It has successfully tablet externally reparented, and we can sort of see here in VT-Gate that it has picked a new set of masters for at least 3 of the 4. Nope, all 4. So all 4 of them now have one. One of them ended up in America. Go figure. If I go back to my terminal, we have resumed inserting data. So just like that, you lose a data center. We did have about 2 minutes of outage here. In our experience, we can get that down a little lower. I've been able to get failovers in as little as 9 seconds. But again, if you tune this too quickly, you can get into a situation where you fail over into something you don't want. So, and then if I go back to my goodest dogger, the Google shenanigans continue. Okay. Well, I am not a very good web developer. I imagine this is my fault. Anyway, the inserts have resumed again. Your database has recovered. Again, you can do this without any human intervention. So all the stuff that you saw me do here, none of this was actually to recover the app. All I did was delete lots of things. We've actually heard some people who use Vitess have had similar situations happen where they have lost enough nodes that they've lost the majority of the masters on their database deployment. Orchestrator kicks in, reparents everything. That being said, it's not perfect. There's obviously situations that still require human intervention, so you can't throw away your pagers just yet, but this is some of the stuff that you can do. I think we're running out of time here, and I did want to leave some moments for questions, so we're going to go ahead and present again. I'm just going to blow through the next couple slides. Like I said, they're ephemeral, so we are restoring from backups and then catching up via replication. We are not using persistent disks anywhere in this. There's a few places where you have less common problems that do require you to actually delete things or interact with the cluster. We have some catastrophic failures, like unplanned node failures. That's when I deleted the one master, or a multi-region data center outage. So right now, like when I deleted that whole region, that was 3 data centers. It's really unlikely for Google Cloud to lose an entire region like that. But even if it does, if you're using Vitess, your database will recover. So the last thing is Vitess is a CNCF project. It is open source. We would love for you to join our community to contribute to the project. If you like databases or are interested in distributed systems, please stop by. It's vitess.io. If you want to join us on Slack, that's really where we do most of our collaboration. If you go to vitess.slack.com, or if you go to vitess.io, you can invite yourself to our Slack. It is found on GitHub. If you really like Vitess and you want to work on it full time, the team at PlanetScale is hiring. We would love to talk to you. So please either email us there or come find one of us. So we do have a few more minutes, I hope. Yeah, good. Nobody said no, so we do. So if anybody has any questions about Vitess or about what you saw or about where I got all those adorable pictures of dogs, you just let me know. Let's go left to right.
I'm curious, you said that it is one copy written to any of the replicas, and you just return the answer that it's written as the application. And if you lose that one?
So it is constantly replicating. Okay, so the question was about semi-sync replication. How if I wait for an acknowledgement from one replica before I say it's okay, what happens if I lose the master and that replica? That's a great question. You have 2 options in that case. One is, it doesn't have to be 1. You can set that number to be whatever you want. So if you want it to be 2 replicas, you can. The second thing you can do is obviously in this situation where I have co-located replicas and masters, right? The place where semi-sync triggered the acceptance is going to be the local one, right? Just the laws of physics dictate that most of the time it's going to be the one that's closest. When I lost that data center, I lost both of those nodes. The way that we have around that is you don't have to turn on semi-sync for all your nodes. The only nodes that participate in semi-sync are the ones that you explicitly enable it. Are we allowed to talk about Slack?
Yeah, so
okay.
Yes, we can.
So one of the people who uses Vitess is Slack. They actually explicitly set semi-sync so that you will never semi-sync in the same availability zone. We've talked about making a mechanism, they do that with their own orchestration. We've talked about making a mechanism like that available in the open source product so that you have the same flexibility. So instead of having to set the semi-sync up to 4 or 5 to make sure that it gets across data centers, you can just say, I only want to semi-sync across availability zones or across data centers. I think we had a gentleman back there. Yep, we'll get back to you. What do you got? So you are not fixed to a given version. I think there are some, Okay, the question was, are you fixed with a specific version or are you limited to only certain features? No, you're not. So we have compatibility from MySQL 5.6 up to MySQL 8.0. That being said, Vitess does have its own SQL parser in it. So there are some things, especially in MySQL 8, that we haven't implemented yet. So I know we have not implemented the JSON portions of MySQL 8. So that if you were to try to issue a query in a multi-sharded environment with JSON, we wouldn't be able to do that for you. If it was single sharded, we would still be able to pass it right through, and whatever your backing version of MySQL was in a single sharded environment, we will handle all of the features. Also in a sharded environment, there are some things that don't work. So let's say you use a stored procedure, and you count on your stored procedure to scan all of your data and then return a result set. That will not work.
But again, I mean, if it's a single shard store procedure that's acting only on data in that shard, that works just fine.
First question, I'm not quite sure to understand if you use an existing technology or solution for sharding or replication, or this is a solution that you develop for within the Vitess project. And the second related question is, what's the impact of this sharding replication architecture on performances? What are the limits, for instance, on the data throughput?
Yeah, so the sharding is built into Vitess. It is one of the primary features of Vitess. So there is no other technology that does it. To the outside application, Vitess looks like a single database. In fact, you can start to deploy Vitess by deploying it. If you're using MySQL today and you're running out of capacity in MySQL, you can actually put Vitess in front of it. It can operate with what we call unmanaged MySQL mode, and it'll just point to your existing MySQL server. Queries can come through Vitess, and they can be serviced by your existing MySQL server and then returned. For reference, so there is no knowledge of Vitess built into the application itself. Here is good as doggo. This is completely PlanetScale proprietary. None of you are allowed to mention that you saw this. So here is good as doggo. It's not a very complex app. You can see that there is just 3 standard queries. This would work the same whether I had MySQL behind it or Vitess behind it. In fact, this just uses the community MySQL drivers for Rust, and it connected right to Vitess. So in terms of performance, which I think was your last part, there is a performance overhead for using Vitess. We have found the performance overhead to be this. There's 2 aspects to it. One, it's going to be about 500 nanoseconds to all of your queries. So any query that you run on any size database, you're going to add another 500 nanoseconds to it, best case scenario. And that's just because you are now going through 2 other processes to get to it. We found if you're doing benchmarking against that and you have sub-millisecond queries, then that doesn't reflect well in Vitess. Under normal operations where you maybe have 10 or 15 millisecond queries, we don't really notice it that much. The second thing that you'll see is that we use anywhere from 20 to 40% CPU. 20 to 40% of the CPU that your MySQL process will use, and that really also depends on the query workload. So in general, Vitess to MySQL, you'll probably see anywhere from 75 to 90% performance as to what you would get over straight MySQL. However, as soon as you shard that, you're now way above what a single MySQL server could do for you.
Exactly.
Anything you wanted to add to that? Anything you wanted to add? Oh, okay, last question.
Couple of questions, actually, if you don't mind.
Nope.
One is the GTID a single point of failure? And second question, or in case of a data center loss. And second question would be, once you lose a master, since you're actually intercepting the communication, you pause it so that the client will not experience any error, wait until resolved and then continue.
Good that you ask, because we actually do that.
So under a lot of circumstances, we do pause. And I could have sworn to you before we did this that we actually paused on these failures as well. Vitess has a built-in buffer for situations like this. So whenever we're doing things like resharding, reparenting, so you'll notice when I did the reparent, we switched masters. Vitess knows how to buffer queries. so that we safely handle that reparenting. We'll actually we'll buffer all begins, we'll allow all commits to finish, and then we will swap the masters, and then we will allow the begins to continue. So it has that buffering built in. That is a great question as to why we don't do it when the backing tablet goes down. And it's definitely something that we are now going to actively try to convince Sugu is absolutely necessary. The second part of that question, I think, was about GTIDs. If I don't quite understand that part.
So, I mean, where are GTIDs located in a multi-data center environment? And what happens if they're only one place in the data?
So the GTIDs are going to be, through replication, they're going to be replicated to all the replicas in that replica set, that cluster. So, and that's the magic of semisync is we're going to make sure that a specific GTID has made it to at least one other node or a configure amount of nodes to make sure that it's not a single point of failure. So as soon as a transaction is ready to be committed, before it actually returns back to the client that it has been committed, it's going to replicate it to one other place. And as the gentleman back there had said, as long as wherever it's been replicated to stays up, then you're guaranteed to still have it. Gentleman in the back.
I was wondering, will that work maybe with managed database systems such as AWS, RDS, something like that?
Yes.
Out of the box.
So the question was, will this work with managed database systems such as AWS's RDS or Google's Cloud SQL or Azure's thing? I don't actually know what it is. Yes, it does. In fact, we've worked extensively with Amazon to get people running Vitess on top of RDS. And we've partnered with Amazon for their Aurora product to show just how wide their Aurora, just how performant their Aurora product is. We haven't published that blog post yet, but it's going to be fantastic when we do. So yes, works perfectly. There are some things that you can't do or that you don't do in Vitess if you're using Aurora. So if you are using Aurora, most people would want to have Aurora manage the master and replicas. So in Vitess, you normally would only, when we've deployed it in Vitess, we only put up 2 tablets. No matter how many actual physical Aurora hosts or RDS hosts you have, we only put up 2 tablets, and then we do it that way, and we allow Aurora to scale the reads. Instead of, in this case, I had a bunch of read replicas, and they could each be managed by Vitess, and it could choose between them. So, but yes, short answer is it absolutely works.
Is there any special orchestrator configuration, or is it just the usual Discover and hope for the rest?
So, Discover is the devil. It does, so we can't use Discover. So there is an orchestrator configuration. It does need a couple extra things besides the standard one. There's a couple post-failure hooks that we have to add specific for Vitess. If you look on the Vitess GitHub page, Vitess has a Helm chart that's developed by the community that has an orchestrator config in it. That orchestrator config is mostly correct. It will generally work for you. If you were on the Vitess Slack channel, you'll notice that recently some members of the community have had some hard times with that. So both preparing for this and then generally because we want to see Vitess succeed, we have a modified version that you're going to see committed probably when I get back to the US. That is very reliable.
Yeah, to add one more thing, the VT tablet needs to be made aware of where the orchestrator is running, and the VT tablet registers the MySQL that it's managing with the orchestrators. That's why orchestrator doesn't need to discover.
So it's orchestrator aware, it knows how to talk to orchestrator.
Correct.
You just specify the API endpoint for orchestrator to VT tablet.
All right. Well, we are, I believe, over our time. But thanks, everybody, for coming and watching. If you have questions, please let me know. If you want to keep rating dogs, because I know it's super addictive, I'm going to leave that app up a little bit, and let's see if it came back online. Oh, you know what? I bet it's the whole thing with Spain. So